Hello, everybody. We are back again with yet another daily recap. We've had quite a few of these, given that we are in day 7 of like active reinvent days going on. I know it's felt longer than that. It certainly has for me. Hi, my name's Nick. I'm a developer advocate here at AWS. We're going to be walking through everything we saw today here on first day of week 3. Joining me as always is Rob Zoo. God, I always point the wrong way, Rob. You're over here, right?
I think there's only two of us on screen. The viewers will get it.
It's okay. In a better world, I could just have production throw me around to make sure that I'm pointing the right way. But we'll not disorient the viewers. Um, awesome. Well, at the top of today, we saw the Werner keynote. I know you and I sat down and recapped that in particular. We're going to talk a lot about that because that was, I'd say, the biggest thing that happened today. There's some other things as well. We had a full 6, 7, now counting on 8 hours of live content here on AWS on air. Hopefully, we'll get some time to walk through the schedule to show you what you missed. Again, all of that will be available on demand after. And if you are tuning in and you're just waking up in other parts of the world, we have some exciting stuff for you. So, in these 30 minutes, we're going to try to cover each of those things. Again, we'll not be able to dive too deep on all of it, but again, that's why this is a recap. We'll point you in the right direction. You can find the other details elsewhere at your own leisure.
Yeah, well, let's dive into this keynote that Werner gave, huh?
Yeah, well, I'm gonna. Sorry, I know I just stopped talking, but I'm going to, in typical Nick fashion, just start talking again. Before the Werner keynote, there were actually some very exciting things, and they happened very quickly. So a lot of people may have missed them. First was actually the Deep Racer Championship race. Again, AWS Deep Racer being this fully autonomous physical vehicle, but an entire suite of tools in order to enable you to train and deploy your own reinforcement learning model such that you can have a model that powers a self-driving car, right? Very exciting. This is not our first time around the block, nor is it many of yours in the audience. This is, I think it's the second or third year that we've been running circuits, both in person and now especially here at reInvent digitally. And we had a championship race where we crowned yet another annual winner. Dr. Matt Wood awarded the winner a trophy virtually, and we've got them unfortunately not joining us here today, but we can bring them in for just a moment. Um, this is our
Nice.
winner. So congratulations to Panchun, who was the winner today at the Deep Racer Championship. So quick round of applause. I wish I had like a clap.mp3 button, but all the applause here at reInvent is reserved for the keynote speakers. So we have to make our own. All right, cool.
Yeah, definitely. And just a quick note about Deep Racer. There's this thing that we have to kind of repeat about Deep Racer, which is that you do not need a physical vehicle to start training your algorithm. We actually have a simulator, and Nick mentioned that it's really easy to get started here. It's actually free. This is a league that really has no barriers to entry, and I know that that's something that we can't really repeat often enough. But one of the things that we definitely want to make sure of is that we get kind of broad participation in the league, because it's really kind of a fun way to understand how a lot of these different services come together to make AWS so powerful.
Exactly. Well, with all of that, speaking of wonderful AWS services, today is not machine learning day. Today was I don't know if there's an official name for it, but it was Werner's keynote, right? And we've come to expect a particular brand of greatness from Werner's keynotes. He usually likes to talk about operating infrastructure, and whereas Peter DeSantis talks a lot about how we do that internally here at Amazon and AWS, Werner often talks about not just problems but solutions oriented towards developers that are using AWS and are just operating software broadly. So I know there's a number of launches here that anybody who's using AWS and using it for more than just hobby projects will be interested in. Is there any in particular that you wanted to jump into?
Yeah, I mean, I guess we can give you a quick recap on major topics that he covered, and then we can dive right in. Werner started talking about kind of the transformation that a lot of companies are undergoing this year due to the pandemic. He talks about some of the customer cases and how they've succeeded on AWS, and they've rapidly pivoted to operating in this new world. He has a couple of service launches around the Cloud9 IDE and particularly the AWS Cloud Shell. And then he talked about kind of provability. Some of these really highly these critical systems that we run that really we can't afford to fail. And even though it becomes increasingly more difficult to prove that they're correct as services become more complex, which he talked about some of the investments there with TLA Plus, one of our provability tools for proving that software actually works the way it intends to work. And then he pivoted to talking about some of our service launches around telemetry and monitoring, and these being particularly relevant to kind of understanding and operating at scale. So that was kind of a very, very quick overview. Now, do we want to kind of talk about each of those topics in turn?
Yeah, exactly. I mean, I'll start with just building reliable and durable systems. I think we said this on the top of the day, and Werner obviously said this in the keynote, but durable, hard, and resilient applications don't happen by accident. If you just happen to, without putting a lot of thought into it, think that your system is durable and reliable, it's simply because a certain threat vector hasn't hit it yet, right? Everything fails continuously. Werner says this every year, and you should shift the mindset from just hoping it doesn't to expecting that it will. Again, this philosophy of I think it was the hopeful pessimism, something to that extent, right? It's like we can be confident and happy with our systems, but also be curious about expecting where the edge cases and the failure cases will come into play. And so, Werner talked a little bit about how there are numerous threat vectors that can put your infrastructure at risk. Everything from scaling up in traffic and demands to scaling down and wanting to be able to right size your infrastructure, to even just entire lines of businesses needing to change drastically. Again, these are not things that we think of traditionally in outside of scaling up and traditional resiliency, right? But they're in this past year, especially things that affect your business and your bottom line when it comes to cost, and that tied into really his broad theme of cost aware architectures, right? We should always be thinking about the costs and we should be optimizing wherever possible. But in a lot of the conversations he's seen with customers, this has really come to the forefront in the last year, both for companies and services that are spiking in traffic and others that may need to scale down to lower numbers or to zero.
Yeah, I'm really glad you brought that point up because that was something that I think Werner spent very little time on, but is very uh, important to keep in mind. When we talk about reliable systems, people often have this notion lodged in their minds of like we're talking about hyperscale systems. We're talking about the Amazon.coms and the Googles and the Facebooks of the world. And yes, certain kinds of applications do reach that scale, and they reach that scale unexpectedly so. But the thing is, he mentioned that reliability at the end of the day is a business requirement. It's not something that you can kind of derive out of just pure technical analysis. And so we take, for example, let's say you have a municipal office for, I don't know, the local department for fish and wildlife or something, and they have a reporting service. That thing might be able to get by with like 20% availability if it just operates on one day of the week. That's might be totally fine based on the business requirements. And you're laughing, but it's true, right? Like the thing is, the other thing that Werner stressed is as you start to build the system, remember we talked about how many seconds of availability. A system with 7 nines of availability is allowed to have 3 seconds of outage per year. And if you think about that, like the amount of effort and the work and the operational maturity it takes to achieve that incremental 9 is exponentially higher, right? What can you do as you slide back down? I think Werner is spot on here. He's asking us to take a really, really close look at what reliability means to the business. This is an honest conversation with yourself, with your company, with your coworkers, with your team about what it is you're building and why it needs to be that reliable and that secure and that. So of course it's a good in a vacuum, but of course that good in order to achieve marginal returns on that, or sorry, incremental returns on that good, as you get more and more reliable, those marginal gains are ever harder to achieve.
Exactly. It all needs to come down to, at the end of the day, and it should, even though sometimes it can be easy for this to get away from us, features and what you're delivering for your end user, right? You mentioned a scenario where the business requirement does not necessitate 100% or there's really never is 100%, like however many nines of availability. And really where we're going with this is it's not just about spending your time in ways that may not return value. It's that this additional durability, this additional resiliency doesn't come without a cost, right? You are inherently going to be trading off either latency or a significant cost for replication or redundancy in order to achieve this. So in on top of your development time, which is one of your most valuable resources, you're investing all of this additional resources or and potentially even degrading customer experience by adding latency to extend some of this resiliency or redundancy. It really is a deep and mature conversation that you need to have internally, and it's difficult for any one person to do that. So excited to see Werner, talking about how we do that at AWS. Another great call out, not from reInvent this year, but sort of if you're interested in this topic of trade-offs of redundancy, resiliency, mitigating failure, Colin McCarthy last year on stage showed how implementing a concept called shuffle sharding enables you to sort of have redundancy and shared sort of transient dependencies on systems such that the resulting uptime of the system can be a product of the constituent uptimes, and through duplicating or having redundant systems you can achieve what you want in a performant way. But again, you can't escape from the cost, right? You can't escape physics, can't escape the speed of light. Like there are a lot of foundational things that you can't get away from here.
Yeah. And then, I mean, shifting back to the topic of, now that if we assume that we are talking about hyper web scale applications, he mentioned the new service launch with AWS Fault Injection Simulator. And this one's particularly interesting because it turns out that AWS is pretty reliable. And it's kind of, it's pretty reliable, but it doesn't mean that you can just ignore faults, right? You're building for failure at every level of the infrastructure. Kind of going back to Peter's point, that everything breaks, right? Eventually, in the fullness of time, everything will break. And if you take that view toward it, kind of Nick, like what you were mentioning earlier, assume that it will happen. It's not a matter of whether it will happen. It's just a question of when. Taking that kind of pessimistic attitude toward ops can really shift the way that you test your services and the way that you look for faults. And one of these ways to look for faults is to look for faults in the control plane. So if your application is making a bunch of API calls, oftentimes it's very difficult to get the control plane or some of the surrounding APIs to actually fail. For example, let's say you rely on DynamoDB. When's the last time DynamoDB went down? I can't remember. But my point is, like, it's very, very hard to test for that case, right? Or what if DynamoDB doesn't actually go down? What if it's actually just being extra slow today for some reason? Not that you can. My point is, it's extremely hard to catch these cases in the wild. And the only way to actually inject those kinds of faults into your application is to write a proxy layer, right? And we see this with kind of a lot of these frameworks out there that implement what's called the circuit breaker pattern. And you see that they kind of embed capabilities and knobs to kind of inject faults in the system. Well, that's a step in the right direction. But now think about that. That's a bunch of code running your service that doesn't actually add to the code. And again, we're going back to Peter's point. We're like, when we build UPSs, we look at the software that the firmware provider is deploying onto that device, and we try and disable all the features that have nothing to do with the day-to-day running of the service. That capability of injecting faults into your service is just something that's waiting to sneak a bug in, or a security vulnerability, or something that you don't want, right? So the ability to kind of punt these kinds of cross-functional requirements into a service like the fault injection simulator is really valuable, because it means your application has to do less, and the less it does, the better off it is.
Yeah, exactly. You mentioned a handful of failure cases, but the reality is that it's unreasonable for any one company or developer to know all of the edge cases for their system, especially before they've happened, right? One of my favorite bits of AWS fault injection simulator is that you actually, by adopting the service, can learn, and not just learn about, but like implement all of these threat vectors for your infrastructure without having to experience them the first time, right? Every single time you're on call and something fails, I guarantee you, if you were the one to resolve it or you had to write that root cause analysis, you will never forget that, right? But why require that to be able to start actually hardening your systems against these threat vectors? So things like, no, like my database provision concurrency hit its cap and it didn't scale up, right? That's not necessarily a bug. But it's a difficult root cause to diagnose, especially in the moment, nonetheless, to solve like properly and effectively in the long term. So fault injection simulator, really strong here, is going to enable like the transferring of this learning, but also inspire confidence that hey, I've tested my infrastructure against these faults, right? I can show that, this deployment before it ever gets deployed to customers passes, these performance or these infrastructure tests, we could call them, right? There's probably a formal term that I'm not able to glean at just this moment, but this is a great dovetail into sort of this broader conversation of solving difficult infrastructure problems, right? Werner talked a bit about tracing and observability, and how, there are so many different data points that exist across a disparate stack, not just whether you're using a monolith or a microservice, but at every layer, right? So maybe I load a website and that feels slow to me. Then there's the actual sort of request that goes and hits the front or forward facing service, maybe a load balancer or an API gateway. And then there's anything behind that, and any number of microservices that you may have behind that, all the way back up the chain until you're serving another response to the user, right? And so, like, it is difficult to correlate all of these sequential and related but not directly linked behaviors that exist across a set of disparate services. And so we saw some launches here that help with that, as well as an example of like the step one in that solution, right? In order to perform this correlation, the first thing is that you need a unique identifier across the entire life of a request to be able to correlate all of the cascading effects from. We see this, and customers can actually see this in something like AWS S3 requests. So I believe there is a key in there in those requests called XAMZ request ID. And so even though a lot of that is abstracted under the hood in the S3 service, when customers and internal staff at AWS trying to debug a problem or trying to deeply understand latency for a given action, this request ID is sort of the keys to the castle to be able to correlate all of this behavior together. And while that's an example of it implemented in S3, customers can be looking to implement this in sort of their own architectures.
Yeah, that's a really good point. I mean, it's not too long ago, it felt like all you really needed to know to debug an application stack was the stack trace. And when you're talking about any sort of service-oriented architecture, really the stack trace is just the beginning. And this is why it's so important to have all those mechanisms that Werner alluded to with logging, metrics, tracing. You really it's just not enough anymore, right? You can have the stack trace, okay, but that's where it went wrong. But what was the impact on all the lying services up and down the stack? You need so much more than that. And a lot of the stuff that he talked about, with, for example, with CloudWatch, these are just things that we have built that where we've solved all these problems. Things like having these correlation IDs, having these tracing IDs that span across the service, including something as simple as just when you try and grep through massive amounts of logs. You talked about the evolution of storing these logs in NFS and then later in S3, and then later moving to a kind of distributed and parallelized processing model in order to serve some of these queries. These are problems that you don't run into when you're starting off at small scale, but you'll be glad that these solutions are there by the time you hit that scale.
Exactly. And to tie all of that together for as far as solutions, or making progress against those challenges, is CloudWatch contributor insights. This was sort of if you're looking to solve this problem of really trying to more deeply understand sort of the end-to-end life cycle of requests, this is what will enable things like canaries to be able to, even before you have production traffic hitting them, send to these test requests essentially with a given ID, and seeing how they'll perform from the front of your application all the way to response, as well as be able to add and tie these unique IDs in at the gateway or the load balancer level, and be able to more easily graph those end-to-end metrics, and those unique it's really not just first order metrics, right? It's assessing of graphs. It's almost like the human element of this debugging, which Werner talked to in a bit, but Becky Weiss actually talked to most concretely in the segment when she was on air. And this quote really stuck with me. I'm curious what your thoughts are. She said, "Automation is necessary, but not entirely sufficient for operations." And I think this sort of juxtaposed with the fact that standalone metrics are not always enough, is sort of talking to this idea that, like, look, we understand holistically how a system is supposed to behave, and when a given metric or an alarm gets flagged, it's important to surface that and send a notification. But ultimately, it's difficult to be able to have all of the context in a formalized system, such that there's always a predisposed known path to resolution, right? Oftentimes, involves real investigative work to try and get down to the root cause, because while you could sometimes implement solutions that are band-aid fixes, true resolution and remediation in the long term involves really getting to the bottom of what was incorrectly configured, what was the cause. And sometimes that's not a technical problem. It's really like either a invalidated assumption about your stack or your infrastructure, or it is something that invalidates one of the aspects of, or one of your optimizations for your business use case.
Yeah, it's an interesting quote, and it's certainly compatible with a lot of mature thinking around operations at this kind of scale. I want to switch gears for a moment and revisit one of the topics that we that Werner mentioned a little earlier in his talk, which is a new service launch, the AWS Cloud Shell, now generally available. And I had the pleasure of taking this thing for a quick tour just today, in fact. And I can tell you that this is exciting. This is going to be part of my daily workflow. I can tell you now. And I think you're going to find the same if you give it a shot. Because this thing is basically, imagine that when you log into AWS, the classic way that you use AWS services is that you generate an API key, you download that API key, you put it into the credentials file, you set your AWS profile, you set it up on your local CLI, and we've all gone through this dozens and dozens of times. Um, but the ability to just launch a Cloud Shell instance right from the console and have all of that pre-configured, it just feels like magic. And not only that, there are some really, really great quality of life features that come with this. Just let me roll them off here. First, Cloud Shell's free. Okay, it's just free. All you pay for are the services that you launch using it, which makes sense, right? The other thing is that it comes with a gig of free storage. So if you have settings, if you have utilities that you commonly use, if you keep that in the home directory, that travels with you, depending on no matter where you launch your Cloud Shell. And then the last one is that this is minor, but this is great. Okay, is that it has this built-in interface for uploading files to and downloading files from your home directory. That gig that I mentioned earlier, you can just put and get files from that seamlessly from the browser. Now, those of you who have done this before, you've probably, if you've copied files to EC2 instances from your Mac OS or your Windows box, you know that the way to do this is to SCP. But then SCP, you have to connect that with your SSL cert. Sorry, no, your SSH public key, and then there's some configuration, and then you usually wrap it into a script. And then if anything changes about that, you have a different instance. Then that's going through that process all over again, right? And not only that, I mean, you're doing this for a lot of times. What customers will do is they'll deploy an EC2 instance as a bastion. And it not only has all those things that you need to configure, you then need to configure like what IP addresses can reach what instances. My point being that there was a lot of craft work to get all this set up, and you do this over and over and over again. And so it's really, I'm so happy to see all that stuff just boil away with the launch of Cloud Shell.
Yeah, exactly. And to the broader customer story being, in the beginning, or the dawn of time, there was just the APIs, right? And then there's the console, which abstracts the APIs, gives you a GUI on which you can operate most, if not all, depending on the service, the operations that are available for the CLI and the API. But developers have said, hey, like, what if I can author my code in a location and execute it in some scenarios that's a little bit closer to where my infrastructure is running? And that was really the advent of Cloud9, the cloud-based IDE plus plus, where you get basically a dev box. And it's more than just a dev box that you SSH into. It has all of the affordances and fixins that you would want to author and execute your build pipelines from within, or just prototype, right? But again, there were some, considerations there, right? You're paying for hourly for this dev box. You want to think about the underlying infrastructure, CPUs, and all of that. And some people only use Cloud9 to just use it as a terminal, right? They maybe didn't really care about the actual GUI for the IDE. Some people just want to use Vim, right, or Emacs or whatever. I'm not gonna start a holy war on this stream here. But it's that's the direct response here with Cloud Shell, right? It's take away the considerations around cost that could have been prohibitive prior, and make it truly as streamlined of an experience as possible to get started. And I think that this free gigabyte of persisted storage, to your point, is enough to solve many of those problems, even if it will not hold my node modules. Um, but lastly, we have just a few minutes here. We'd be remiss if we didn't talk about the launches of Amazon managed services for Grafana and Prometheus. This sort of uh, fleshing out the matured observability and visualization story that we've been seeing here very recently. Rob, you and I spoke with the AWS distro for open telemetry team to help better instrument applications such that that data can then be pushed to other sources. And some of the most common questions you and I got on that stream, as well as the service team clearly has gotten, was, what does this look like for utilization with Grafana? What about Prometheus as an agent that's collecting these metrics and distributing them elsewhere? And seeing these standalone managed services for each of those, it basically just tells me that AWS is committed to meeting customers where they want to be for observability and instrumenting, right? Lots of customers are already using OpenTelemetry. Lots of customers are already using Grafana. Lots of customers are already using Prometheus, and sort of meeting them where the shared responsibility model has this sort of sweet spot around, you want to author code that interacts with these services, but you don't want to have to manage the hairy bits around the ops for it. Seems to be a win-win and a continuation of a lot of trends that we've seen in the space.
Yeah, agreed. And this is really the other side of the coin, right? When Werner talks about these complex systems that are going to inevitably fail, Werner and Peter both, um, if they're going to fail, then what you really need is observability, and these services cut to the heart of that, making observability as turnkey as possible.
Wonderful. Well, unfortunately, we're out of time. I want to give a few seconds to segue into what we have coming on immediately after this daily recap. Let me pop over to the handy dandy schedule. All right, cool. So we are at, sorry, I know this is not on screen, but we are at about time here. Next up, we have the certification quiz show with MJ Bailey and Nelly Lachakova. That'll be for about 30 minutes before we cap off the English segment today with an industry live session with CPG, which I've been told stands for Consumer Packaged Goods. So if that's the space that you're in, learn a little bit about what has been launched that could be relevant to you. Um, so Rob, we've been live for about 8 hours today broadly. Not you and I. We've had a lot of help, lots of really exciting sessions. But the important call out there is that we will be back for more. We will have another full day of content tomorrow on Wednesday as well as Thursday. If you're just waking up or you're in another part of the world and English is not the language you'd like to consume content in, we have some other daily recaps. Hopefully, you've seen them. They've been going on for the past 2 weeks as well. But again, those being in Japanese, Korean, Italian, German, French, Portuguese, and Spanish slated for tonight. So if any of those are your jam, stay tuned. We have that all on the schedule. I'll drop that in the Twitch chat. But I can hear in my ear that we are over on time. So fortunately, I got to jump off. It's been a real pleasure, everyone. Thank you. Hope you enjoyed Werner's keynote. Without further ado, next up, certification quiz show. All right. Have a good night, everyone.